All right, welcome everybody to another live stream. In this live stream, this kind of Q&A, I have three questions that were previously sent in to me. First of all, we have solving. I believe we're just going to actually find, let's kind of find all the solutions. Find all the solutions for tan of x equals the negative square root of 3. And then we're going to look at one for find the domain of a function where we have a double radical, a radical in the numerator, radical in the denominator, and then we have some quadratic expressions underneath. And then I have some evaluate logarithms. When you have a logarithm and you're trying to evaluate for a fraction, basically between a number between 0 and 1. And those were submitted to me either on my channel membership or they're also submitted on Facebook. So if that is something that you would be like, if you have some questions that you'd like me to kind of go through, and I, throughout the week, and maybe like to go through them for the next live stream, then please feel free to go ahead and reach out to me. I was a little bit late as far as posting this on the Facebook. I do apologize. But one thing I will be planning on doing, this Sunday and Monday, try to put out at least a little notification for you guys to let you know that I'll be going live and just doing an open Q&A. So there is another Q&A. Obviously I will be doing live stream another time, usually when I'm going to go over a quiz that I've been teaching in my class. But not always when I have the quizzes am I able to really get to your guys' questions. So that's why I wanted to do this kind of open Q&A as a new sort for this year. So therefore I can answer your questions. But again, guys, I'm not going to get to everybody's questions, especially once these live streams kind of get going for like 20, 30 minutes. Then I just start getting flooded with questions. So the best bet is if you do have a question, feel free to, submit it to me prior to the live stream. And then you can always check in if you, aren't able to join us live. However, pending on time, I might have some time to answer a couple more questions. So if you are in the chat and you do have some questions that you'd like for me to kind of go through. I can't answer everything, but I hope I'll be able to help you guys out. And I look like my stream strength is a little low, so hopefully the latency and everything else kind of seems all right, but it seems like it's doing okay. So I did want to let you know I did want to go on this live stream tonight because I'm not sure if I'll be able to be posting any other videos since this hurricane Dorian is coming through, and obviously I live in Florida, so we'll probably be making a determination as far as the internet and what we'll be doing for that. So either way, it looks like a pretty powerful storm. So hope everything is in the best. So Atham, I believe is your name. Super chat for $3. Thank you very much. I'm in Calculus 3 and differential equations now, and you helped me a lot. Well, you are very welcome, and I'm so glad to be a part, because I don't teach a lot of the calculus. I only taught a couple of years, but obviously that telling me that you're in those courses now tells me that you obviously followed my videos from the pre-calculus or even algebra 2 to really build up a lot of those foundations, because those are some good serious courses that making sure that you have a lot of the foundation going with. So thank you very much for the super chat. That is greatly appreciated. Let's go ahead and check in, see anybody else is who else is in the chat here before I go ahead and get started. So Andrew, just want to say thank you. You are very welcome, Andrew. Arrow shout out. Was that Hyro, I believe. Fernando. Tom S., what are you teaching this year? Tom, I am teaching pre-calculus again, all pre-calculus. It's good. I like to kind of focus on the certain, but last year I taught all pre-calculus, and I'm kind of one of those people that really needs kind of variety. So I was really hoping to kind of get back into the calculus game, just because I feel like that's where a lot more of my newer videos can come, because obviously teaching algebra for so many years and geometry for so many years, I have so many of those videos, so calculus is something that I'd like to build up. But otherwise, it's going pretty good. I feel like I'm refining a lot of my lessons, and I'm enjoying that. Yes, Wang, thank you very much. Definitely stay safe. Cabo Akko, please say. Actually, I promise I don't even know what that's saying, what I'm saying, so hopefully it wasn't anything bad. What drives you to continue posting these videos? NT said, no, it's Nick's G says, going after graduating, also help you through. That's very awesome. NT, very happy to be able to help you out. Very good. Bra Monkey, I appreciate it. And Wolf Moscow, I want to ask a YouTube related question. Do you think it's worth to start a tutorial channel? I teach mathematics as well. I really enjoy it, but I want to do it as a side hustle. I mean, I think the whole point is, you know, when you're looking into doing something on YouTube, and I'm in a lot of groups of people that are trying to grow YouTube channels and, you know, all this kind of stuff. I mean, obviously I have over 300,000 subscribers now. So a lot of people look at that and say, wow, you know, like you're doing really well and all stuff. But, you know, the main thing is, I mean, I was doing this YouTube channel for, 7 years, I think under, 30,000 subscribers. I mean, so, and even like my first 5 years, I mean, I was like, you go back to like, look at my analytics. I mean, I taught for like 5 years posting videos, almost multiple times a day and would just get no views. Nobody was really watching my videos. Then you get like one video that somebody watches. So, I mean, and I still go through this approach. I post videos online to help somebody. It's kind of like, I don't know whose this video is automatically going to serve, who's going to get some information from it. But it's amazing. Some of my older videos, somebody, people will watch them and they'll say, oh, that, helped me out so much. Thank you so much. And, you never know until you start posting some videos. And I think the other thing that's really helped me with the videos, I think as far as a teacher's perspective, is really my explanation, because when the record button's on, it's easy to kind of, to shortcut sometimes in class or kind of go with the class. But, that's something, as far as slowing down and breaking things down for my students, has really come from a lot from me knowing that I'm recording myself and also to help people, online. So I think from a teacher perspective, there's nothing wrong or nothing that's going to be a negative from recording yourself and posting them on YouTube. And who knows who knows what's going to come from it. I mean, and I think that's the main thing. As long as you enjoy the recording and teaching, and just go with that. And you know what, years and years on, see what happens with the channel, see, what the growth and all that kind of stuff can be. But I'd definitely say, just go for it. Just, enjoy teaching. I mean, that's why I kind of turned into the studio, so I don't have to rely on being inside the classroom. I can do these live streams and I can make more videos, more often. And it's just something I enjoy doing. It's not something that is, limit or, I feel like I'm always pressured to have to go and do it. Jake with Soup Chat, thank you so much, man. I really do appreciate that. Wow, guys, you guys are definitely getting into the chat on this Sunday. I guess I'll have to keep on going with the Sunday, even to this holiday weekend, at least for us in the States, even with a hurricane coming in. Like, I don't even think I'm going to be teaching this week based on this hurricane and the path and everything it's going into. So, all right, guys. Well, I do have I do want to make sure I get to at least these 3 questions and not just chit chat my whole way through the live stream, although I did do this Q&A live stream, so therefore I can interact and say hi to some of you guys that have joined on, so I do appreciate it. The one thing I will say though, guys, is I'm going to do these 3 questions as I'm kind of teaching through these. I'm not going to check in on the chat, so if you do have a question that you'd like me to go through, one thing that I do notice, I know it's very easy to say you need help with this or you need help with that, but if you can be very specific, these are problems. The reason why these got chosen to kind of be on my live stream is they're very specific. They say, I need help with this question or, explaining this. So therefore, and obviously I'm going to go on top of like that explanation, but I have at least some concrete examples to go off of. So as you're going through the chat, if you have any questions or anything else you'd like me to do, I can't do everything. Obviously, again, I kind of focus on Algebra 1 to the calculus, and so any kind of questions from there, like me to explain, all the better. So, all right, guys, let's go ahead and get started, and then I'll come back into the chat and get into some questions. So the first one is solve trigonometric equations here, and we're going to work on all the solutions. And so there's a couple different ways we can visually look at this. The one way I look at this, because we solve this in our analytic trigonometry portion, but you can look at like where this is the graph. And if you remember the tangent function here, the tangent graph repeats on and on and on, right? So first of all, we know that when tangent of x is equal to a negative square root of 3, wherever that is, right? I just know that that is going to be an infinite number of solutions. Now, However, if we're to understand where these solutions are, the graphical approach is not really going to help us, but what can help us is understanding our unit circle. So remember, the unit circle is represented by those points where, let's do that again. All right. So the unit circle is represented by points that lie with all have a radius of 1. And there's basically 3 major points that we need to know, at least in this first quadrant here. And that is going to be the square root of 3 over 2, comma 1/2. We have the square root of 2 over 2, comma the square root of 2 over 2. And we have 1/2, comma the square root of 3 over 2. Okay, so basically those are 3 points, and one thing when we're teaching this, we go through that. Now the next thing is we need to understand, well, what exactly is tangent representing, right? Tangent's representing the y-coordinate over the x-coordinate. So out of all 3 of these angles, forget about the negative for a second. Let's just figure out which of these angles gives us the value square root of 3, right? Which of these when we take the y-coordinate over the x-coordinate? Because remember, the tangent of any angle, right, is y over x. So here's the y-coordinate and the x-coordinate, and we need to figure out which one is going to give us the square root of 3. Now, hopefully, you can just recognize here by at least kind of doing some math and to kind of simplify this, we can see that it's going to be this angle, which based on our unit circle is going to be pi over 3. Now, the problem is, though, that's a positive square root of 3. So we got to figure out when it's going to be negative. And what we can do is look at reflections here. So we know that that same angle, same reference angle of pi over 3, but in the second quadrant would be 2 pi over 3. And again, you can see that's correct because this would now be negative 1/2 positive square root of 3 over 2. Okay? And then we have this angle down here, which has the exact same reference angle of, again, pi over 3, but now it's going to be short of a revolution around the unit circle, which would be 2 pi over 3. 2 pi. So therefore, in terms of thirds, that'd be 6/5, so that's 5 pi over 3. And that point works, again, makes negative square root of 3, so that's 5 pi over 3 and 2 pi over 3. Okay. So what was I trying to do? Oh, okay, yeah, the coordinate point. So that coordinate point is 1/2, comma, negative square root of 3 over 2. And both of these, again, when you take the y over the y over x, you can see that's going to give you a negative square root of 3. So therefore, I can just say the solutions here is x is equal to this angle, which is 2 pi over 3, and this angle, which is 5 pi over 3. Okay, so these are our two kind of angles. Now, the thing to kind of know, this is a really bad tangent because if you recall, there's asymptotes for the tangent graph, and these graphs repeat. And basically what we need to see is the graphical approach is how often do these graphs, how often do these points repeat themselves? And, on our study of the graphs of tangent, we saw that they repeat themselves every pi. And let's kind of make sense of that. Like if here is a solution, right? This is an angle that makes that equation true. Well, if we add pi to that angle on the unit circle, obviously, like add pi to it, it's going to take you to there, right? You're going to keep on getting this point. On the unit circle, though, you can see if you add pi, it takes you there. You add pi again, it takes you there. So how many times could we add pi? Well, infinite many times. How many times could we subtract pi? Infinite many. So to represent that, we use a letter, and typically N or K or C is a letter we'll use. I don't even remember what I use in my class, so I'm just going to use N. So I'll say pi N, where N is going to represent any integer, positive or negative. Positive, it's going to represent going to the right, and negative would represent going to left. But since, again, tangent repeats infinitely, that's how we can represent all of the solutions. All right, moving on to the next question. It says, find the domain. And again, in this example, guys, we're going to want to look at the graphical approach to understand them. So let's go ahead and graph x squared minus 4. So x squared minus 4, 1, 2, 3, 4. And let's see, that's going to cross at 1, 2, 3, 4. 1, 2, 3, 4. So understanding my shape of a quadratic, I know it goes over 1, up 1, over 1, up 1, and then over 2, up 4. So actually it's going to cross at positive 2, negative 2. There you go. Okay. Oh yeah, positive 2, negative 2. And again, you could find your solutions by the graph if you aren't sure if I did that right. Just set x squared minus 4 equal to 0. And then you can say x equals plus or minus 2, right? Those are the x-intercepts, the solutions to the graph. Now let's go ahead and do, so that was the graph y is equal to x squared minus 4. And now let's go into the other graph, which would be y is equal to 9 minus x squared, which is probably easier to graph as a negative x squared plus 9. All right, and if we do the same thing, set the negative x squared plus 9 equal to 0, you can see x is going to equal plus or minus 3. But now this one is opening down, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, so hopefully we have these graphs complete. So therefore you kind of have a basic understanding of at least what the two graphs are. Now the reason why I wanted to provide these two graphs is because we need to understand the restrictions here of our domain. So, or of our domain for this function. So we have basically 3 restrictions that are going on. At least in this class, or at least in this kind of unit, we talked about you can't take the square root of a negative number. So we have a square root in the numerator and we have a square root in the denominator. We cannot take the square root of a negative number. That means everything that's under the radical, known as the radicand, has to be greater than or equal to 0. But we have another issue. We have a denominator, and we know that the denominator cannot equal 0. So in this example, so for instance, let's do the first one. So since we can't take the square root of a negative number, we know that x squared minus 4 has to be greater than or equal to 0. That's it. It has to be positive, but it can equal 0. There's nothing wrong with the square root of 0 is 0. However, we can't do that for the bottom radical because if it's equal to 0, that means the denominator is equal to 0, and that's an undefined value. We can't divide by 0. So therefore, what we're going to do for the denominator, or the radicand in the denominator, is just set it to greater than 0. Now, we don't want to solve these algebraically. What we're going to want to do is look at the graphs. So in this case, we're looking for what values is the graph larger than 0. So here's the x squared minus 4. Which values is x squared minus 4 greater than or equal to 0? And you can see here that this is going to be greater than or equal to 0. That means it's above the x-axis for, let's write this out, from negative infinity to 2. Actually, you know what? Let's do a number line. So this one, so anything, so here's negative 2 and here's positive 2. Okay, so it can equal negative 2 and it can equal positive 2. But anything to the below negative 2 or above positive 2, right, is going to be above the x-axis. Now, if I go ahead and do that with my 9 minus x squared, I say, well, when is that greater than 0? Well, that's greater than 0 for any number larger, or for any number to the right of negative 3 and to the left of negative 3. So that one's going to look at, let's see, here's negative 3. Here's positive 3. But again, those are open circles, and it's all values in between, right? So now basically what we're going to do to identify the domain is we're just going to put these two graphs on top of each other and identify the intersection. So let's have negative 2, 0, 2, and let's do 3, negative 3. So you can see here, we have there, open circle, open circle. Okay, and again, we're only going to graph the where they intersect. So that's going to be between negative 3 and 2, and between 2 and 3. That's it. So to write that domain and using interval notation is going to be from negative 3 to negative 2, intersect, union, 2 to 3. And there you go, ladies and gentlemen. That is how to work. So that's a good question. I never actually haven't done one of those in my class. So that's a good one. I like that. Thank you. All right, next one is evaluate. Well, so I think really to understand this one, we got to understand what it means without fractions. So what is log base 2 of 2? What is log base 2 of 4? And what is log base 2 of 8? So again, remembering the understanding of logarithms, basically this is saying, 2 raised to what number equals 2? Well, that is 1. 2 raised to what number is 4? Well, that is going to equal 2. And then 2 raised to what number is 8? That is 3. Because, I'm just going to do this. Ah, shoot. come on. Okay. All right, let's go back to that. That one's 3. And again, you could say 2 to 1 is equal to 2. Put it in exponential form. You could say 2 squared is equal to 4. You could say 2 cubed is equal to 8. So this is what we call the logarithmic equation. This is called an exponential equation. And you can see how they're related to each other in this form. So if we want to put this in logarithmic form, we're basically asking ourselves, 2 raised to what number is equal to 1/2? And this usually gets, kind of confusing when we first introduce it. So the important thing is to kind of go back to our exponential form and like exponents and think about, the rules of exponents, different ways that we could represent exponents. Because over here to the left is exponential form. This is not written as an exponent. So therefore we say, well, how can we rewrite 1/2 as an exponent? Because the important thing is, one last thing is this, property of equality. If I said, 2 to the 5th power is equal to 2 to the x, well, then you could just say, x is equal to 5, right? So as long as we have this property of equality where the bases are the same, we can set the powers equal to each other. So, but before I can do that, I got to set 1/2 equal to a fraction. So again, understanding our rules of exponents, we recognize that 1/2 is equal to 2 to the negative 1st power. So therefore, if this is really equal to, actually, let's move this. Let's move this down. So if I say 2 to the x is equal to 2 to the negative 1st, that means x is equal to -1. And that's exactly right. 2 is first to the negative 1st power. So in this case, for the next one, kind of gets a little bit tricky again. We're going to use a couple of rules of the exponent. So 2 to what power is equal to 1/4? Well, we recognize we can rewrite 4 as with a negative exponent, right? 2 to the x equals 4 to the negative 1st. Okay, got that. But the problem is you can only use the property of equality when it's to the same base. So therefore, can we write 4 with a base 2? Of course, we can rewrite that as 2 squared, right? So 2 to the x equals 2 squared times -1. And again, remember the rules of exponents, that when you have an exponent raised to a power, you can just multiply. So 2 to the x equals 2 to the negative 2nd. Now you can see x is equal to -2. And hopefully you start recognizing here this relationship. So therefore 2 to 1/8, instead of being 3 here, is going to be a -3. And that is how you work with fractions. Use your rules of exponents to help you out with that. All right, and I thought, oh no, that was all 3. Sweet. All right, let me get back into the chat with you guys. See if there's any other questions that kind of came through for you, and see what I can do to help out. So Enzo, finding square roots. Again, if there's anything specific that you guys did not add, if you can add that into it, I'd greatly appreciate it. I only have a couple more minutes. I only wanted this live stream to be roughly around like 30 minutes, so I don't really want to go too much over. Find the derivative of 6x squared plus 7. Then evaluate the derivative at x squared and x5. Is that 6x squared, I assume? Puzzle Master, please make sure you confirm. I'll do some. I'm okay to do some calculus. I don't want to overstretch myself just because I'm not currently teaching it, and it's not something that I have taught a lot of. I only taught 2 years in high school, so therefore a lot of the problems I like to have. Therefore I want to make sure that I have a little bit more work. Find the domain. Okay, Mark, I don't know. I mean, to graph 4x plus 7 minus x, I'm not sure. I mean, I'm not sure. I wouldn't be able to. I can show you how to find the domain range of that, of the absolute value, if you would like, Mark. But as far as adding with that 7x, that's kind of, or that 4x, I would just use a graphing technology to go ahead and do that. What's up, Kitty Gamer? How are you? Good to see. Yes, AP Stat is going pretty good. Well, good. Very good. Don't be giving me AP Stat questions. You can. I'm just not going to answer any of them. So don't worry, because I would not be of any help for you. But glad to have you back on the chat and keeping me honest, as always. All right. All right. We can do a little bit of that. That's cool. Absolute value. Yeah, okay. I'll just do the domain range for that. No problem, Mark. I'm not sure how that 4x is going to impact a graph. I would recommend just going on to Desmos and looking at it. So hopefully, after I give you hopefully after I kind of give you some information on mine, then that will help you out. So y equals absolute value of 7 minus x. All right, cool. All right, guys, unfortunately, I am going to have to end off the submissions. I'm sorry if you got one in there. If you tried to submit one in there, I only have enough time for 2 more and 2 more questions, but I will plan to be back for next chat. And again, I will try to put the questions out there, or at least the time that I'll be going live, which typically will be around this 9 p.m. Eastern Standard Time. And therefore you can submit your questions, prior, so I have enough time to prepare on this document so I know what we're going to cover. And then you also have enough time to, give me some questions and we can clarify what they are. All right. So let's go get into some differentiation. Usually this early, I'm not sure how everything else you have worked on with as far as using your differentiation rules or using the, quotient, not the quotient rule, but the difference quotient. Yeah. The difference quotient, find the derivative. I'm just going to go ahead and cheat and first find the derivative. So we recognize, or at least to kind of do a quick thing here, if I wanted to find, like f of 2, then remember, you're just going to plug in the number, right? And for x, so it would be 6 times 2 squared plus 7, right? So just remember, we're trying to evaluate a function here. That'd be 4, so that's 24 plus 7 equals 31. But be careful, because that's not what our question is asking. Our question is asking, what is f prime of 2, f prime of 5? So we need to figure out what f prime is. So in this example, it's relatively basic. Once you're out of calculus, this is something that, you're going to remember. It's, usually using this power rule here to basically you take the power, multiply it by your coefficient. So in this case, we're going to have 12, and then you are able to subtract 12x. 7 does not have a constant, so this is a constant, so basically that's going to go to 0. So therefore, our f prime is just simply as 12x. Therefore, to find f prime of 2, we're just going to plug in 12 times 2, which equals 24. And f prime of 5 is just going to be 12 times 5, which is 60. So what you'll notice is taking the derivative of polynomials is relatively something you're going to kind of enjoy. And, once you just get some practice, obviously there's definitely some more difficult examples that you want to do. But the main important thing is really understanding this notation, understanding the derivative notation, and understanding what it means to evaluate a function. So again, I'm not sure. There's obviously, you can break down this power rule and make it a lot more sense of it. But I'm just going to, for sake of time, I'm just going to kind of use the simplified version and show you how to quickly find the derivative and then to go ahead and evaluate. All right, the next thing is find the domain and range of the following function, y is equal to absolute value of 7 minus x. So there's a couple things that we need to understand here. First of all, the parent function. All right, so this is something that we're going to learn in my class that I tell students all the time. If you see a function and you're asked to graph it or identify any characteristics, you need to know what that function exactly looks like. So here's the absolute value function, over 1, up 1, over 2, up 2. Left one has the same properties. This is the lovely V-shaped graph because it looks like a V. Okay, so automatically from understanding this parent graph, we can recognize a couple things. The domain here is going to be all real numbers, right? Because this graph expands to the left and to the right. And the range in this case is going to be from 0 to infinity. Again, make sure 0 is included, right? And then it's going up to infinity. All right, so now moving on to the next thing, we need to understand the transformations. What is this doing to the graph? So there's a lot of different ways we can go ahead and understand this. Before we can go ahead and do that, what I tell my students to do is rearrange everything so it's in the format that we can identify everything. So first thing I do is I rearrange this to be a negative x plus 7. And then we talk about c and b, you have to factor out that negative. So therefore, this is in the form negative x minus 7. And this is very, very important to understand it in this regard. And what we notice is there's only two transformations that's going on. We're multiplying by negative. Our x is being multiplied by negative, and then we're subtracting by a 7. So we need to understand what those transformations are. So to understand those transformations, we need to know the generic transformations to any function. Well, we can just use our parent function here and just say all the transformations are a times b x minus c plus d. So these are all the transformations. If you're unaware of what A, B, C, and D do, I do have notes on them, but I definitely make sure that you are comfortable with understanding. Quick little review. A, vertically stretches or compresses the graph. D, vertically shifts the graph up and down. B, horizontally compresses and stretches the graph. And C is what shifts the graph left to right. So these transformations are all the same. It doesn't matter if it's an absolute value, if it's a quadratic, if it's a cubic. They all impact the graph the same. The only thing that changes is really the function, absolute value, square root, whatever the type of function is. So the main thing, though, is I had to if you leave it like this, a lot of people will make their mistakes and they'll leave it in this formation where really you need to put it in this formation to put it to really truly understand not only the b, because the b didn't change, but you can see when I factored out the negative, the c went from a x plus 7 to a x minus 7. Very, very important to understand, because again, you can check my work here by just plugging this into Desmos and seeing how the graph gets transformed. One thing I forgot to mention, when a is negative, that's reflected about the x-axis. So therefore, when b is negative, that's going to be a reflection about the y-axis. So let's just write down all the transformations. So we're reflecting the y-axis, and we're going to the right 7 units. So remember, when that's 7, it's x minus c, right? So it's like x minus c, or x minus c. Right? So c in that case is actually positive, right? When you do x minus 7, 7 is actually positive. That's why it's actually going to the right. The formula is x minus, but therefore it's just some things that you need to understand in that regard. All right, so we have right 7 units, good. Reflect the y-axis, got it. What was I trying to do? Oh, domain range. All right. So now to understand the domain range. Well, the cool thing about this graph is the domain's all real numbers. So it doesn't matter what transformation I'm going to do, the domain is always going to be all real numbers. So that's a cool thing. So you only need to worry about the domain or the range changing when it's restricted, which you can see the range is actually restricted in this graph. So therefore, these transformations could impact the range. But actually they don't, because all of these transformations are horizontal. Right? So if I take this graph, I shift it left and right, if I reflect it, it doesn't matter. Anything I'm doing horizontally is not going to impact the range. The only two placements that would have impacted the range is if I would have had some A's and some D's. Anything outside of the function, shifting the graph up or down, or if that would have been a reflection about the x-axis, that would have impacted the range. But since none of those happened, my range is actually the same. So I spent that whole time explaining everything to tell you the answer is exactly kind of the same. But hopefully, if you have a question similar to that, or at least you have a better understanding, from there. So not too bad, guys. I only went three minutes above my live stream, so appreciate that. So just imagine practicing information. Yes, that is very much TJ95. Range 0 to a negative infinity. No, it's not, because this is not a reflection about the x-axis. That's a reflection about the y-axis. So the actually graph is symmetrical already about the y-axis. So therefore, it's not really going to look different. If there was a negative on the outside, then it'd be a range of negative infinity to 0. So hopefully that helped you guys out. All right, guys. Well, I think any other questions I have from there? All real numbers, no domain. Yeah, very good. All right, awesome, guys. Well, thank you so much, guys, for joining me in on the live stream. And again, I will be going live next week. I think my channel might be a little bit slow on the live streams for this week. I think the internet is not going to be cooperating for us. So hoping that the storm is still going to kind of stay off the coast. But unfortunately, that's just going to be one of those things that we don't really have much of a choice in. So we'll just do our best. But I will look forward, though, to having everything ready for next week, and also probably getting another video here uploaded for you guys to send on your way. All right, guys. Anybody else that's in the range of the storm, please stay safe, and I'll talk to you guys soon. Next video. Cheers. Ah. Ooh. No, it won't. Come on. Yes. I was thinking it was going to... Ah, no. Okay. All right, bye.